Thanks. So good to see everybody. Happy Friday, and thanks for sticking around to the end of the conference. So she did a good introduction there. Excuse me. Today we're going to talk about Kubernetes. We're going to look at it from an architectural perspective. When we design our multi-tenant types of systems, where we, for example, have lots of different platform teams maybe consuming the same architecture. So we're going to look at how to isolate our services, what the container runtimes provide, what the orchestration frameworks give us, and we'll look at some kind of patterns for authentication, authorization, as we build out services and give people access to do things like spin up services, kill things, deploy, pull secrets, and things like that. So she did a good introduction. That's me, Jack. That's me teaching my daughter manners on the left. If anyone wants to hire a Golang developer, she's maybe got a couple years till she's there, but she's really expensive. Do most of my dev these days in Scala and Go. I got the Go bug about a year ago and just do quite a bit of development there. And I've been running Invisium since 2009. So what is Kubernetes? I'm sure everybody in here has either run Kubernetes in production or at least heard about it at this point. So Kubernetes is a system that lets us deploy and scale our containerized microservices. So generally, we're not doing things with the Docker daemon like spinning up a shell script and running a lot of containers. So we're generally using an orchestration framework that handles things like scheduling, resource allocation throughout a cluster, things like that. It gives you a lot of security scaffolding, and there's a lot of good things you can do. I feel like I'm screaming into this. But at the same time, there's also a lot of nasty things you can do as well. You can move really fast. You can overprivilege things. So lots of times we see people give people access at the cluster level when they could be kind of pushing that down to a namespace. So the way you initially kind of roll out your platform is probably the opinionations that you're going to keep to the very end. So some of those things you do want to think about early. How do people kind of build and design around your systems? So with regards to isolating containerized workloads, so here's an example of a Kubernetes cluster. So in the top box, we see the Kubernetes control plane. So that includes things like the API server, etcd, which is the key value store that backs the API, the scheduler, controller manager, and all the key components of the control plane. So if you pop the control plane, get root to that, it's most often game over at that point. You have the ability to pretty much do whatever you want to those containerized services within the cluster. So generally you have one or more masters, and then you can have essentially 0 or more nodes. So basically nodes are generally where your containers actually run. So here's where the container runtime runs in that stack. So we can think of Docker, we can think of other container runtimes we'll talk about that we can swap in at that layer. And as we can see, we end up spreading those maybe between nodes, right? So one service could be running in pods across maybe multiple nodes, right? So we have to think about how that kind of security boundary stretches. Things like user privileges, right? We have to replicate those across hosts. So those are some considerations there. But we want to keep you in the container, right? So think about a multi-tenant environment where you have 20, 30 different app teams deploying to a common platform and infrastructure, right? We want to make sure that we have clean isolation between services, that we can't move laterally. We make it pretty hard to elevate privileges. But in reality, we often make it pretty easy to attack other services. So we expose services, which means that we expose essentially a TCP UDP access to other containers. So lots of times we have the ability to call out across namespaces to talk to other containers. And sometimes we'll also run with shared privileges where we may end up running with shared privileges in the cluster between, which means they could do things like pull secrets for other applications if they're running as the same account. So we want to think about how do we kind of get out of the container and attack other ones. And if we have that level of access, we can do things like run API commands. So we want to be really careful what we can do with other containers. We also want to protect the actual node and control plane components. So there's been a bunch of vulnerable kind of defaults out of the gate for the kubelet over the years. That have made it a little bit easy to kind of attack a host. If you can basically compromise something like the kubelet, you can use that to kind of get more privileged access to upstream to the API, so on and so forth. And you can also attack the API itself, right? So most things that actually happen are API driven, including things like pulling secrets, access to volumes, and things like that. So if you run, or for example, you can pull the service account token for another service, you can impersonate that at the API level. So different things to consider in terms of what we want to protect and isolate. But in a multi-tenant environment, we really got to think about these things. When we deployed things like monoliths, we had kind of separation, right? We ran like a VM, and in reality, we use a lot more shared infrastructure. And then the container runtimes, the daemons, also heavily use host resources. And we'll talk about things like namespaces and control groups. And we have a blurring between who does what, right? So there's kind of, sometimes in groups I've seen, they have it really figured out. Sometimes there's not a clean delineation point between who does what anymore, right? So is it up to the developer to, for example, securely configure their pod specs? Or does somebody else do that and they're just up to basically the Docker file, right? There's really no one size fits all, and what I've seen is it definitely depends on team size, composition, maturity. But it is interesting because what you do kind of see is that sometimes there's fumbles. Somebody was doing something at one point and somebody's not doing that now. So when people migrate their architecture, these are kind of some of the problems and trying to figure out who does what. And in a multi-tenant environment, there's things that platform team just straight up doesn't care about, right? If they provide you a secure platform to operate on, then they put a lot of the security decisions back to the developers that are building various microservices. So it is important to kind of figure out who's going to control what. So in Kubernetes land, K8s is a real easy way to kind of abbreviate Kubernetes, so we'll use that. We talked about having masters and nodes. So the master is pretty much the brains of the cluster, and then the nodes are what end up doing a lot of the work. With regards to pods, so pods are essentially allows us to represent one or more containers, meaning that we can deploy containers with some dependencies and everything like that. So we do have tighter coupling when we deploy things like that. But then there's also things that break down to that security model when we share container resources within a pod. And workloads are just different ways we can build resiliency strategies and how we deploy things, how many instances that service needs to be running, so on and so forth. More often than not, we have a Docker file. So you're seeing more container runtimes that you're able to use now because of things like OCI specification and Kubernetes is CRI runtime interface. But most often than not, we're using a Docker file, right? So we're generally extending from an image. We can push in things like environment variables, which we have much better routes to do than pass those in via environment variables. And then we pull in our code. On the right-hand side, it just kind of shows how Docker's evolved to how it kind of works now with its daemon, containerd, and runc. But essentially, you have a fat daemon that ends up spinning up container instances. So generally, that's using things like C groups and namespaces within that Linux system. So I'm not talking about Windows much today. I don't really spend much time in Windows land, which I know Windows has things like, for example, Hyper-V integration, which kind of goes outside of some of this. But generally, when we're running Linux containers, they're not really great sandboxes. So we use things like C groups and namespaces, which if you've looked at container escapes over the years and ways to kind of get out of Docker and others, they've often been things that haven't been incomplete namespacing of resources and stuff like that. So you've been able to jump out of the container in that way. So with regards to being a great sandbox, it's not. But we end up enhancing that model by using things like seccomp to block syscalls, using AppArmor to lock down things like capabilities and different entitlements you have on that system. So these things aren't perfect, but we have that as an option. Some of the container runtimes have better defaults out of the gate. Docker does pretty good there. With regards to giving you a hardened seccomp policy out of the gate if your container actually supports it, but you do have to use those things, right? OCI specification allows us to use more container runtimes now, so CRI is kind of the hook for that. And if you look at what that ends up doing, it cleans up just a lot of the spaghetti code with trying to implement different container runtimes, but gives you some standard interfaces that you can use. And things like default capabilities are pared down even more from like the OCI specification, as opposed to things you even get within Docker's defaults. But obviously the container runtime generally builds upon those as well. With regards to isolation methods, that's kind of the traditional route we just looked at, using things like namespaces and C groups. We won't get too deep into some of them, but I like to just kind of give everybody a sampling of what's out there. GVibes is a cool project spun out of Google. They use a user space kernel to essentially do things. So whereas Docker runs highly privileged on the host, they run a user space kernel. You have a subset of all the syscalls available, and you don't actually pass those to underlying system. So it kind of proxies them essentially in gvisor land. which reduces a lot of the surface for getting out of that container and elevating privileges and attacking things on the host. So this is something you could flip on fairly easily nowadays. Some of these things are less stable probably than Docker in honesty, but I like where they're going with security. Hypervisor kind of mode, using things like clear containers that spun out of Intel that's now Kata containers. It allows you to run your container inside of an actual hypervisor, which they use like QEMU Lite basically, which gives you basically the first layer of what you get in isolation from the container, and then you also get what you get the hypervisor level. So you do make it a little bit harder to jump out and attack things on that host. So control groups and namespaces are how we do things in Docker land, which I imagine most of you are running. Does anybody, just out of curiosity in here, run a container runtime in their environment that's not Docker? Any Rocket or, no? All Docker land in here? Okay. But we do see things like, for example, times, not fully namespace. So we do want to be careful when we grant the container the ability to do things because those actually impact the actual system itself. As for the different container runtimes, this is a good table. It just kind of gives you a sampling of what the runtimes provide out of the gate. So you can see where things stack up with regards to, hardened seccomp, AppArmor, the ability to actually do things like drop capabilities, do things like limit the ability to escalate privileges. Honestly, Docker is probably the furthest along in terms of all of them, just because people have put a lot of time and effort into Docker. So in the cloud native architecture that we're going to be running on Kubernetes here, these are some of the most important things, right? So container isolation we've been talking about, really important and essential in a multi-tenant environment. We'll look at the control plane a bit now. The control plane, again, if we can compromise the control plane, we have a really bad day. If we think about a couple months ago, if anyone remembers when Tesla had a Kubernetes cluster popped, it was like exposed API server and they were a dashboard and were able to basically do things inside of that cluster and launch crypto miners and things like that. So this is one of those things where you can have it hidden behind things, or you can drop security groups in AWS and Azure fairly quickly and expose these resources. So I have seen people expose these things and have problems. Things like, for example, network segmentation are very opinionated. Do you, for example, do really strict segmentation, or do you use something like Istio and just kind of set some really hardened defaults, right? And then poke holes in that. That's a thing I've seen kind of be a religious thing. Everybody has their own way they want to do that. But things like authentication, we have to think about how, again, the container authenticates, and also how now we get into users and people that are going to be deploying services, having the ability to pull things like secrets. So we obviously want to know who they are, and we obviously want to limit what they can actually do in that cluster as much as possible through things like role-based access control. And secrets management is something that's supported pretty first class in Kubernetes, but people often default back to really bad practices. And we'll take a look at some of the options there. So control plane. First off, we have things scoped at the cluster and namespace level, right? So things that are scoped all the way at the cluster level propagate down to namespaces. And this includes different things we're going to hit through the API server. And there's also things that are non-namespaced as well, or they're non-resourced rather. So we have a couple different ways of communicating and getting access to objects in the cluster. Namespaces, when we start building out our cluster, essentially allow us to split out the environments. But we get some isolation there in terms of like the scope of where things like secrets can propagate and how far your RBAC privileges go. But once we start doing things like exposing services, well then we have network access across namespaces. So that does break down, and that's not really a hard boundary in that regard. But things we want to do to protect the control plane, right? We want to do things like set resource quotas for namespaces and do those things at the pod level as well. To make sure that one misbehaving container can't consume an unlimited amount of resources and start bringing down control plane components. So we do want to make sure that we kind of limit that scope. So from the control plane, we took a look at that. We have the master, and then we could have zero or more nodes. If we have 0 nodes, and that means we're running containers on the master, so you can actually taint the master. Basically to run and run containers on it, but it's not something that's supported out of the gate. And some of the security model obviously breaks down if you're running those things on the master, right? So we don't generally want to do that. We want to run at least one node. And if we're using a managed service like AKS, EKS, GKE, they give you managed control planes. You have a little bit less control over what you can actually configure there. But I mean, it does take a decent amount of work off your plate where they manage the control plane, which is often one of the hardest things to do to harden, keep up with, restrict access to. So I've seen people do things like give all their developers SSH access into master because they didn't want to do things like expose the API endpoint in a different way. So this is a place that you can overprivilege what you give people. More often than not, you don't need to give most of your team SSH access to the master, right? Because if you get onto that master and you have privileged access, you can read things, especially if you know, etcd is going to be on there, which is your key value store. You can do things like read all the secrets, right? So you can encrypt secrets at rest, but it is fairly weak, right? So this is one of those places I stress you, like, don't give people SSH access into the master unless they really need to. But now we get into where these workloads start to spread across nodes, and we start to kind of open up holes where we can poke in those. And how do we actually call things? There's various API groups, and essentially everything is RESTful, right? So we can communicate using pretty much REST calls and bearer tokens. And earlier on, it was kind of a little bit flatter, and they've broken things out quite a bit into different API groups. But the good thing is that because things are broken out into API groups, and within those API groups, you have more granular resources, things like pods, things like secrets. So you have things that you can kind of bubble down to, and you can give people more granular role-based access control to those. So as Kubernetes has moved things out into APIs, you have more access and control over that. And things you can do with the API, for example, if you are a container that has privileges to run, say, for example, using like shared service account credentials, you can actually do things like run API commands over REST, right? And this is something if you've, again, like blocked, like, you know, incoming firewall stuff, and so you're restricting inbound network access to a container, this is something that's still going to work because there's essentially a service that runs at the kubelet that allows you to essentially still send containers in. So this is outside of kind of the behavior of what you can harden at the actual container itself. So you can obviously limit the scope of these attacks by, you know, keeping privileges for people low and not sharing credentials between containers. We can also do things like using mission controllers within the control plane. So at the API server, we can do things like set pod security policies, force you to pull clean images to, you know, limit the amount of malware that can kind of get shimmed in there, and different things. So we can actually enforce these as admission controls when you actually get admitted to the cluster. So we can do things, for example, like say if your container is deployed with things like, you know, root privileges, well, we're not going to allow you to pretty much, you know, come in the cluster doing that. So you can kind of set that first wall of security controls, take some things out of the, you know, developer's hands or DevOps or whoever's building those pod specs for you. You also have different authorization modes. So most build tools nowadays will turn on things like RBAC, and they'll also turn on the node authorizer. So the node authorizer is nice because it limits what the kubelet can actually pull from API server with regards to things like persistent volumes and secrets. So basically, if the kubelet doesn't actually own that pod, then you can limit what you can do upstream there. So that is one of those things that if you want to limit how bad a kubelet attack is going to be for the rest of your cluster, then you definitely want to have the node authorizer enabled. So let's talk a little bit more about the pods and containers themselves. So those are some of the things you kind of run into in the control plane. What I've seen is a place that people go wrong. So you can just, you know, roll things out with the defaults, and you're probably more often than not fine in a lot of cases. Different deployment tools. Does anybody use a tool called KubeSpray in here? No? KubeSpray is really, really bad with their defaults. Things, for example, like they enable etcd on all network interfaces, and then they drop things like mutual TLS between clients and peers. I'm not sure if they've, you know, maybe fixed that within like the last month, but that was something that I know to be open. And I've actually seen people deploy clusters with that, and, you know, thankfully they've been able to fix that stuff. But it's one of those things, if you're not actually looking at the opinionation that the build tools are using or the deployment tools, then you can actually end up with a lot more security issues than if you would have just ran using like kubeadmin to build your cluster. So the pods and containers are where we kind of get into, you know, pushing things down. So some teams, you'll have a dedicated platform team that runs the control plane and all that stuff. And then, sometimes that may be developers that are running control plane. But where we get into where, this gets pushed down to developers is more at the pods and containers level. So let's take a look at how we harden those. So pods are the smallest deployable units in Kubernetes. So we can have one or more containers inside of a pod. And within those, we can do things like set security context and pod security contexts, where we can set some first line of kind of defense in our pod spec that actually happens above, essentially, if you look at the order, the container manifest, right? So we have the ability at that level to, set different runtime flags for the container runtime. That gives you the ability to kind of control that, one step closer to actual deployment, right? And using pod security policies on the other side, you can actually do enforcement of those things that you're trying to push standardly. So the security context, here's just a simple table that shows you what you get at the pod level and what you get at the security context level. So a few things do overlap, but essentially the rule of thumb is that if you apply something at the security context level and at the pod security context level, then the pod security context, the security context at the container level actually takes precedence. So it's always closer to the container. So if you do have overlapping settings, that's going to be how they're going to be resolved. But essentially, there's things you would want to apply at the security context level. You have that assurance that any container that's running within that pod is at least going to have those things set, right? With regards to things like base image management, so I would like to tell people, honestly, keep your container images as small as possible. Limit the amount of packages, right? Don't build from extend from the biggest image possible. Things like Alpine have had issues recently, but you do want to kind of favor containers that bring a lot less kind of packages, because every one of those packages is something that's essentially got to be patched, or what's going to end up being a post-exploitation tool for an attacker that gets on there. So, right? Things like curl, right? Stuff like that maybe you need it on there, maybe you don't, right? So if you can limit those packages, great. What people also run into is that you'll want to use containers that actually don't support some of the things we're talking about here. So they have to be compiled with support for things like seccomp and AppArmor. So it is one of those things that you do want to check, because again, the container runtimes do give you some security, but you actually have to have support compiled into your kernel to actually be able to use those things. And you can run those commands if you want to just do a quick sanity check. And one other thing is using specific version tags when you're pulling things down as opposed to latest. If you're pulling down container latest, then you don't really know what you're getting, right? And you don't have that same control over versioning which goes into your environment. So I do always like to tell people use image tags explicitly wherever possible. So talking a little bit about seccomp there. So seccomp allows us to start filtering the different syscalls that we can use. So essentially the different Linux syscalls allow us to do pretty much all the privilege operations that we actually do that's supported by the kernel. And there's a lot of dangerous ones that honestly you don't need. And as we restrict those, we essentially start the container from a much more restricted starting point. And again, seccomp's been supported for a while. It has first-class support in Kubernetes, and you can apply it at the pod level, and you can also enforce those things at a pod security policy as well. And AppArmor, for anyone that's not familiar with AppArmor, Docker also does have a strong default AppArmor profile. By strong means like they've considered some basic things that containers don't need, right? In reality, if you were going to build an AppArmor policy by hand, it would probably be a lot more strict. And if you were to use any tools that would actually profile, for example, the different capabilities used and the different files that you access, there's a handful of tools that allow you to actually do that with AppArmor, then you would get a much more restrictive policy. But in reality, most, honestly, Java developers aren't that deep into things like AppArmor and seccomp and SE Linux. So if you can get by with the defaults, that's great. And I'll show you in a minute how you can set those. But yeah, if you want to actually build those, then there's tools out there to kind of give you a leg up as well. Capabilities are another thing. So basically, once upon a time, root was all powerful. Root got broken down into a bunch of different capabilities that we can give it. So things like capsysadmin and ptrace and some really dangerous capabilities are blocked by default with most of the container runtimes. We can turn those back on really, really fast if we need to. But we can a lot of times keep those things off. But sometimes I've actually seen security tools that actually do require you to run significantly privileged. So some of the container security tools that are out there right now actually do require you to run things like ptrace and capsysadmin. So you do kind of get into a realm where you need to maybe allow some namespaces to have some of those capabilities in order to use those tools, but you could also, if you were to drop everybody into a namespace, highly overprivileged what those containers can get, because you'd have to poke holes in them for some security tooling that I see used pretty heavily in the industry right now. But yeah, if you can basically limit things down to the Docker default capabilities, you get rid of a lot of different attack vectors, ability to abuse network interfaces, elevate privileges by abusing things like set UID and set group IDs and stuff like that. So kind of cool if you can limit this. More often than not, we can basically get down to something like that where we're using net raw because we need to use ping, right? I can't stress that enough. And we'll look at for example, things that we also often share are access to network. So on the host, for example, in the network namespaces, we often kind of cross those over, and IPC, as well as process IDs and things like that. So pod security policies allow us to mutate things on emission and enforce some minimals. So more of the build tools now, I don't believe they all turn PSPs on, so you usually do need to enable this, and I think the managed platforms all give you the ability to use pod security policies as well. But basically there you have to have that emission control flag enabled. And there's a couple weird rules there that kind of throw people off. Really the one is like the alphabetization of how things are picked, but essentially if it is an update, then it's going to be rejected from that perspective. I don't know how well you can see. I think you can see that hopefully well in the back there. An example on the left is a pod security policy. So at the left, we'll just kind of drill through all the pieces there. Let me make that just a little bit bigger. So up here we have different annotations. So what we're saying there is that each container, we would prefer that it pulls and uses those profiles, right, for seccomp and AppArmor. So by default, that's going to default to like container runtime. For Docker, that's going to use Docker's secure defaults. But that also caveats that we have compiled support in our kernels to use those things. Going down there, things like privileged, right? We want to restrict can you be root. Things like allow privilege escalation, so that limits the ability to set UID and group ID flags and elevate privileges. So you end up working with the effective UID of yourself at that point. So that's the ability, but you can actually set that and enforce that. And then we have a couple things that allow us to limit what you can actually consume on the host, IPC, namespace and stuff like that. And we can also limit which users the containers can actually run as, right? So we can use, for example, a min of 1 and a max of 65535 for user IDs to limit using user 0 as root, right? So we can set these things, and that we have some assurance that when we're deploying, that we have some minimums that we're adhering to at that point. This originally derived from OpenShift and their security context constraints. So if you work in like an OpenShift environment, then you can pretty much apply the same methods to what we're talking about today. And you can apply different pod security policies as well. So you can have more than one, and these are applied at the cluster level as opposed to actually at the namespace level. And we do have to attach role-based access control, so that's kind of the one that if we don't have roles that are actually privileged to pull that policy, then they can't consume them. So you do want to make sure that you use role-based access control for that. So another thing we can use is user namespaces. So newer kernels do support the ability to do this. Docker has support. Kubernetes, it's kind of buggy. But you essentially at that point remap who that user is on the actual host to essentially a high numbered UID that has essentially no privileges. So if you're able to essentially compromise the container, then you have limited abilities to kind of do things on the actual host kernel. So to do that obviously in Kubernetes land and do that in a distributed fashion across a cluster is hard, so there's been bugs with that. But you do, if you can enable that feature gate, then you can actually use that ability, which essentially that's the flag that's getting passed in a Docker to do that. Rootless containers are kind of another thing as well, so we can run our containers with essentially without root. Things, for example, like building packages and doing installations require privileges. So seeing the kind of different rootless tools and techniques, they essentially use file system snapshotting, and they won't actually ever give the final container root, and they'll just incrementally change what that file system looks like and then give you an unprivileged container to work with. So Run C supports those things, and it's been fairly limited. Surprise, Kubernetes 1.12 actually does support it. So if you were to use the pros mount security context attribute, then you could actually set that. And so obviously you can leave that blank for root. So I don't know how well it actually works in production. I've messed with it. I've looked at the code. Let me know. No new privileges, another thing as well. So we talked about that. We can set that in our pod security policy with allowing privilege escalation. Essentially that limits the ability to elevate privileges. So essentially if you're using like, something that has, root privileges on a binary, you're not able to basically use those. You're down to like effective privileges. So the whole theme here is that you want to limit what that attacker can do and elevate to and jump out of that container with. Read-only containers, this is kind of one, if you don't do stateless stuff, then maybe you can work with like a read-only root file system, but these things don't work maybe in all cases for everybody. So, authentication. Authentication happens at a couple different layers. The API has to authenticate users and developers. You have to authenticate nodes to the cluster, so when we join a new node, we generally have a token that we join up with and authenticate ourselves with, which don't generally change. We have things like webhook endpoints that we can send things from. We can tie those things into admission control. So when we think about authentication, there's a couple different surfaces that we need to consider. Kubernetes provides a handful of different ways to do authentication, ranging from basic auth, X509 certificates, using JWT tokens, which is one of the options we can look at. Things like basic auth obviously aren't a great idea for many, many reasons. User passwords are stored in plain text on the host, et cetera, et cetera. They get sent in every HTTP request, so usually want to avoid those. Really no same way to manage things. Most people default to things like X509 for developers. Subjects, so a user can be a developer. A subservice account is generally what the containers get privileges as. See people abuse service accounts to do things like dashboard access. So they create a service account per developer or whoever needs to access the dashboard, and then they use that JWT until the end of time. So that is one way you can also abuse service accounts. The one thing I guess that stands out there is if I tell people don't use basic auth and tokens and things like that, like those in some cases might require like a cluster restart to flush those things out. So you do want to avoid some of those routes. So service accounts, so one token to kind of rule them all there. So by default in each namespace, you get a default service account. So if you don't actually use an explicit service account for it, then you're essentially using that same service account across pods, which means that they all have the ability to pull the same secrets, run container commands and others. So this is where you kind of want to get into creating a service account per. Earlier versions of Kubernetes, there was kind of some weirdness between etcd and checking the tokens, basically, where if a user was removed and the token, the JWT still passed all the signing and integrity checks, then it would still work. So that's kind of cleaned up by default now, where it'll actually defer to etcd to make sure the user exists. So in each basically namespace, you get a default, and that's actually a fairly easy fix there, right? We create a user for each one, and then within that pod specification, we actually use that service account, right? So problem solved at that point. They're all going to get their own JWT tokens, and then you could actually provide, use RBAC to, give them limited access opposed to their all shared privileges across things. Talk a little bit about authorization. So authorization is fun because we can really overprivilege things, and by default, you see, a couple people get cluster admin out of the gate most of the time when people set up a cluster, and then they either start to give people lesser access or they give everybody cluster admin. And that's really hard to rein in like a year later when you have to have arguments with people about their access levels and why they have too much. Role-based access control that allows us to restrict those things, and we can set things at the cluster level, and we can also set those at the namespace level. But we essentially start from, first we create a role. So on the left-hand side there, we create a role called read pods. We give it the ability for the API group there. So by default, that's like the core objects. So, the standard things, pods, containers, and, all the primitives that have been around for a while are within that group. From that, we can get a little bit more explicit and get down to the actual resources themselves. So we can get even further down from, that in the pods to even limit what you can do within pods, right? But then we can limit what you can do from a verb perspective. So there we're just pretty much doing essentially read types of things, right? So get, watch. So watch in Kubernetes land is something that interfaces with etcd that allows you to have a watch on an object that changes. And if that changes, you can get basically you consume that event. But at this point, we're not giving it the ability to do anything that's like state changing, right? Kill services, mutate anything running, so on and so forth. On the right-hand side is how we actually bind that to an actual subject. So we have, in that scenario, we have a service account, and then we're actually doing that in a namespace at that point. So that's actually an example of like a namespace, right? So we're not giving him cluster ability. The thing that you usually see people kind of go wrong there with is adding a lot more of the API groups, I guess, out of the gate than you need. A lot more resources, giving you all verbs, right? So you can use like a wildcard to do that. So again, anytime you do access control and start these things out, start from as little as you need. The thing too with Kubernetes RBAC is that it's also cumulative at that point, so you can't actually take away any role-based access control. You can only grant at that point. So if you have multiple roles associated with you, then it's just basically, it adds all those up and determines what you're able to do. And if you actually look at the code where it actually, essentially does those role-based checks, it's just essentially just a set of like nested loops, right? It starts with the API group, goes down to the resources, and then it goes down to the verb. So it's like 3 layers of nested loops at that point, and how it actually checks those things. Which kind of confused me. I had been writing some automation tools, and those rules just kind of took me a little bit to kind of figure out. So maybe they're more obvious to you, but I had to play with that for a bit. We'll kind of end here on secrets management, and then happy to take any questions. So secrets management is one of those things that you can kind of butcher pretty easily. So lots of times people provide secrets in the form of environment variables. So if you do the environment variable route, then essentially those are available to any process within that container. So you don't get the ability to do like things like discretionary access controls, right? So it's just basically in like a set command, it's there. With regards to using the actual secrets management facility, you do get the ability to mount a secret and have a little bit more control over it. But we can also do that pretty poorly as well. So the top one there is an example of running Docker with like -e flag for environment variables. That's what you see a lot of people do. That is the worst way to do it because it's going to show up in things like logs. It's going to show up in things like shell history and so on and so forth, right? And maybe the scripts that you're also using like launch those things off, right? So if you can avoid this form of like secrets management, then do it. There's totally better ways. Kubernetes has a secrets management API, so you can use kube control to create the secret. And you can do that from either file or you can pass those as like command line values. So that's a better way to do it because you're essentially using Kubernetes' facility to bootstrap those containers with the secrets, and they mount those as a volume. But there's kind of some downsides there as well. So it's still stored in plain text by default in etcd. So when I was telling everyone, like, don't give people like SSH into like your etcd and masters, like this is why, right? If you can read etcd, which again is a key value store, right? Then you can pretty much dump secrets at that point. So depending on your tolerance for risk, this is either a horrible thing or something that you expect. You can encrypt them as of 1.7 and up. The downside is that you also have like symmetric encryption key stored within basically a flat file that you still have to store somewhere, right? To basically encrypt those secrets at rest. So it's only encrypting them inside of etcd at that point. It's not actually encrypting them, for example, if somebody has RBAC ability to actually call the API and pull secrets on behalf of that, right? So what you get at that point is you get encrypted storage like at rest, right? So one place. Better than you get out of the gate, but not perfect in a lot of kind of scenarios. And then you see people using integrations with things like Vault. So this is from an OpenShift blog. I didn't actually make that myself. But essentially kind of the workflow there is that you can use the service account token to essentially identify what service is unlocking a secret in Vault. And then if you make an HTTP call out to it, you can grab an individual secret at that point. So what ends up happening is that you can mount that and make that available to the container. But it's not actually something that's, for example, persisted within the cluster at that point. So then you kind of get some separation there between like storage in the cluster and then storage in another place. But then you have, again, all those practices, like are you using the same service accounts for every single service? Because then every service can still basically use that token to unlock the vault, right? So you're basically taking the same problem and you're just kind of shifting it to another place. Seeing kind of with the managed services and seeing things like, their key management solutions with the different cloud providers seems to kind of become the first class approach to doing this if you're using like a managed service. And I kind of like, the kind of set it and forget it approach to, rotating secrets and managing access and stuff like that. And here's just a simple script. Basically what you end up doing is essentially before the actual container lifecycle starts in container, you're using essentially curl to call out to it. You're using that service account token that's mounted in that host itself, and you do the API call, use that as a header, and you can unlock the secrets that have been stored within that vault. And then when you actually go to actually spin up the container itself at that part of the container's lifecycle, it has that secret available to it that it can use, right? But it's not persisted at that point within the cluster, which is very different. That's my show, everybody. So hopefully the things I talked about today, think about security early in that process. The more, essentially namespaces you stand up and the more microservices you launch, the harder it is to kind of clean these things up and the sprawl and the technical debt that you're going to accumulate out of the gate. So definitely think about, the kind of patterns, how your teams kind of organize around code and projects, how tightly coupled you want different services and things to be, and kind of architect around that. Definitely focus on the logical and organizational structure. You want people to be able to move fast, but you also want them to be able to move safely, right? So hopefully we've seen there's things that you can push and let the developers do, or whoever, DevOps team, engineers, AppSec, whoever basically manages those things. But you want to make sure that you also have, different layers of controls that are going to block things. So things like emission controllers and stuff like that are really important to have in place. And apply security controls to the layers that make the most sense. So some things may make sense to, build an elaborate scheme out for doing things like mutual TLS between services. Or you may want to use something like, Istio or Envoy that provides that infrastructure for you, right? So it really does depend, I guess, on, size of team, capabilities, how fast you want to run, and things like that. Any questions? Yes? I'm sorry, can you repeat that last part one more time? Oh, so I like using something like a Vault or, pulling that out of etcd. There's other things out there. There's commercial products that do those types of things. But I like, especially if I'm using like, a cloud platform, then I'd want to use whatever, key management solution is there. I always, me personally, I favor, first class implementations, implement it into things like their IAM infrastructure and stuff like that. So, if I had my pick, then I'd want to use approaches like that. So does that answer that? Okay. Yes. So what he said in terms of how we'd actually run something like etcd, we'd run an etcd cluster where we have some replication, and the answer is, I mean, I see people do it both ways. They'll run them on the masters, and sometimes you do see them split out to their own etcd. In terms of, I guess, what I would prefer at that point, it's not bad to have them outside of the master. But then you still have, I mean, the same things you need to do at that point, right? Limit essentially who can talk to those, implement those same controls. I mean, if you can do, out of master etcd replication, then sure, then it's not a bad thing at all from a security perspective, resiliency perspective, and having a little bit of separation between etcd and the masters, right? So absolutely, I don't disagree with that. But the reality is, then you have to have another couple boxes dedicated to run etcd at that point, right? So I mean, you could run into those things. Depending on the team and how much just computing they have available, I think is going to dictate that. But mm-hmm. 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 So he basically said, would you look to use something like OpenShift as opposed to like stock Kubernetes? So, OpenShift obviously is like an enterprise model to it, but having said that, they do a lot of good things from a security perspective. Things like etcd are well hardened out of the gate, right? So there's a fair amount of, things like good security control plane hardening there. But I mean, at the same time, you do run into a lot of the same issues and a lot of, things you can still kind of, shoot yourself in the foot with regards to over-privileging containers, not using things like security context constraints properly. And then you get into, obviously, all kinds of CI/CD pipeline issues and pulling things from different container registries. But the nice thing about OpenShift is, there's, nice integration with their container registry, OAuth and things like that. So yeah, I mean, if you're able to use a solution like that, then it's great. But again, I mean, Kubernetes itself can be secured to a similar level, but OpenShift does a lot for you. Absolutely. Yes. Mm-hmm. So your question was people, I guess, accidentally copying files from the host into or giving access to? Mm-hmm. Right. Right. So I guess your question at that point is how do you avoid stuff like that? Not specifically, no. So his question was, I guess, just what are people doing, I guess, or is there any, I mean, I see people use a handful of different tools to do kind of validation of what's happening in the containers and stuff like that. So the short answer is I don't know a specific tool dedicated to doing that, right? But you could build something that's, fairly easy to grep and run as a webhook every time you commit, right? So, yes. In terms of, could you repeat that one more time? I don't hear it.
How many of the patents that you talked about are already covered by Twistlock, Sysdig, or Flare? Versus none of them are covered because this is all control plane.
Gotcha. So what she asked was, what do the different, commercial tools provide out there for security hardening that you, I guess, wouldn't get out of the gate of the things we talked about today? So the short answer is there's a bunch of different tools out there, and not going to get into like what each one of them does or does well or bad. They all cover a different part of the surface, I guess. So, depending on which one, right, you maybe have less emphasis on like, pipeline and, deployment kind of stuff and more on like, composition analysis, right? So to be honest, I haven't seen one tool that does everything you need from really getting control plane right to, understanding the code that's being deployed, asset inventory, right? I mean, everybody does kind of a little bit of each, segmentation. So it is one of those markets, cloud native right now, that there's a lot of room for innovation and there's a lot of like unanswered things out there, right? So yeah, hope that answers that. Any more? Yes. Yes. So what he asked was, we talked a little bit about using the service mesh pattern, so using things like Istio and Envoy. And he asked, what is the security, I guess, upside of doing that? So the short answer is that what we end up doing is deploying a sidecar container with our actual container. And what we end up doing is abstracting a couple different security operations out of it, right? So things like mutual TLS, you don't really need to worry about that inside of your container because it's handled by that sidecar that's essentially a proxy into that, right? So that's handling things like mutual TLS. That's handling things like access between microservices. So for example, if this service shouldn't be talking to this service, then you can handle that from a key management and identity using like service accounts, using things like Spiffy and Spire or the, so you get that that you can offload. You can even offload a little bit of like monitoring and detection stuff, right? So things like those, like Istio and Envoy, using the sidecar, allows you to do things like distributed tracing, right? So a lot of times we find that teams will spend a lot of time and money monitoring things like ingress and egress choke points, but they have absolutely no visibility what happens inside of, for example, a set of microservices, right? So using a sidecar, they give you the ability to do a form of distributed tracing where you can basically have, it essentially puts a marker in there so like this came from like the service, for example, right? And so you can, do things like Grafana and other like tools to visualize like dashboard and actually see like, for example, so, if you're looking and say, I want to know like, for example, this, this service is having issues all of a sudden, whoa, like, basically like, network utilization from this host spiked. It gives you the ability to do that. You don't have to build those things into your containers. And you can allow them to be pretty much as small and dumb as possible and have that intelligence kind of built around them. That is a good pattern, and that does seem to be what a lot of people want to do these days. There's definitely some complexity in running things like Istio. It's certainly non-trivial in implementation perspective. And things like, for example, you might get, we introduced latency because we put a proxy in front of basically the service, right? In reality, that latency is going to be fairly low in a lot of cases. Now, I'm not going to say that there's not, streaming and real-time apps that's not going to have a tangible impact on. But, for more, services, I see that not being a huge issue, that they've got the I/O pretty fast at that point, that that's not a huge performance impact. So those would be the things I'd imagine someone would ask, and that's how I'd answer them. So any more questions? Cool. Well, thank you, everybody, and have a happy